Welcome back to Applied Mathematics. In this video, I want to talk about using formulas, which is one of the easiest problem-solving strategies that exists. The idea here is that if you are trying to solve a particular problem and you don't really know how to approach it, you might look up in some reference source like Wikipedia and read about a formula. So you may or may not have studied this particular formula at some point in the past, but I'm going to assume that this is a formula you have never seen before and approach it from that standpoint. You can see that there's a wall of text behind me because I don't want you to have to sit and watch as I write it all out. Let me get my head out of the way and we'll go right into it. The height h in feet of an object thrown into the air with an initial speed v0 in feet per second after t seconds is given by h equals v0t minus 1/2 gt squared, where g equals 32 feet per second squared is the acceleration of gravity. If a cannonball is fired upward at 325 feet per second, how high will it be after 1.7 seconds? All right, if a cannonball is fired upward at 325 feet per second, how high will it be after 1.7 seconds? All right, I'm going to try to keep most of this on the screen, but there's only so much I'm going to be able to do and still actually write out solutions. But I want to introduce you to the approach that I use for solving problems with a formula. I take my page and kind of divide it up so that 1/3 is on the left and 2/3 are on the right. On the right, I write down my formula. In this case, we're looking at a formula we're assuming we just looked up, so we only have one formula to think about. In other situations where you have several formulas that might be relevant, at this point I would write down all of the relevant formulas. I would then, on the left side of the page, line by line, write down every variable that appears in the formula. So we've got h, we've got v0, we've got t, 1/2 is not a variable. We've got g, it's a constant, but we'll call it a variable here. And then we've got t, which we already wrote down. We don't have to write it down again. All right. Now I go back to the problem. I look through and I write down every value that I know. The first one, g equals 32 feet per second squared. That's really easy. G is 32. The cannon is fired upward at 325 feet per second. Feet per second is a speed. That's going to be my v0 here. How high will it be after 1.7 seconds? 1.7 seconds is a time. I guess that's going to be t here. 1.7 right there. And then how high will it be? Well, how high will it be is the value of h in this particular case. I'll put a nice question mark there. All right. Your hope at this point is, first of all, you should have one question mark, and second of all, you should have everything else filled in. If that's not what you have, then you had better hope that you have extra equations. For every question mark and for every variable that has nothing next to it, you need to have at least one equation written down. Or possibly there's one equation that has several of these blanks that you just didn't need at all and you can cross out, and then you can eliminate some of the blanks and then you can get it down to that point. All right, in this case, we're fairly simple. We have one equation, we have one question mark, there are no blanks. This is going to be a very straightforward problem to solve from here. Because at this point, I just plug things in. H is unknown, so it remains unknown. V naught is 325. T is 1.7. 1/2 is 1/2. G is 32. T is still 1.7, and it's being squared here. Right. Calculating this in two parts. If I take 325 times 1.7, my calculator gives me 552.5, but I'm kind of down to just two significant digits here. So I guess I have to round that and call it 550. Then I've got 1/2 times 32 times 1.7 squared. My calculator tells me that that is 46.24. I again only have two significant digits, so I'm going to round that and call it 46. And then I want to take 550 minus 46. My calculator tells me that's 504, but that 550 was rounded to the nearest tens, so I can't write down 504, I have to round it. It would round down in this case to 500, not up to 510. The tens place is significant, the ones place is not, so I'll put a macron above it to remind myself that that zero, the first zero but not the second, is significant. And then looking at all of my units, I've got feet, feet per second, and feet per square second, and seconds. So from that, I could conclude that this was a measurement in feet, even if I didn't have what I do have, which is the units of feet given to me in the original statement of the problem. All right. I don't think that going through more examples like this is going to be that much beneficial. There are situations where you have more than one formula. There are situations where you have to deal with rearranging the equation as you plug things in. There are situations where you have to go through and solve for a thing that you weren't asked for, plug that into a different formula and continue from there. But the basic idea here of using this structure to organize yourself, I think, is very useful. Especially when you're not sure what formula to use, writing things out like this can help you eliminate things that are not helpful. Right. The other thing that I want to talk about before I wrap this video up is a concept known as solving literal equations. Right. A literal equation is an equation that has several variables in it and not really much in the way of constant values. Every formula is a literal equation, but not every literal equation is a formula. A formula rises to the higher standard of it has some physical meaning in the world or in some sort of an application. That's not a distinction I want to quibble about, but I did want to give you the official name of this, solving literal equations, so that you can find it in other sources if you so desire. But the idea here is if we go back to that same equation, we'll go to the same formula we used before. H equals V naught T plus 1/2 GT squared. I'm sorry, that should have been a minus, not a plus. And you might be instructed to solve for G. Right? It looks a little bit weird because it's all variables everywhere and not much in the way of a constant in sight, but it's still something we can do, so sure, why not? The first thing I'm going to do is get rid of this fraction. I don't like fractions. I'm going to end up with a fraction, but I don't want my fraction to have fractions in it. So to do that, I'm going to multiply by 2 on the left-hand side, and I'm going to multiply by 2 on the right-hand side, although I have to be very careful to make sure that everything on the right-hand side gets multiplied by 2. That needs to be distributed. So I'll have 2h, I'll have 2, v naught t, and then 2 times 1/2 cancel each other out, and I just have g t squared. From here, I'm trying to get g by itself. It's got this extra term on the same side as g. That's a problem. So just like you would subtract a constant solving a linear equation, I'm going to subtract the 2 v naught t from both sides of the equation. It doesn't really clean up any because it just changed things around. Now I have 2h minus 2 v naught t on the left-hand side, but at least on the right-hand side, I just have minus g t squared. And then to get g by itself, I'm going to have to divide by t squared, and I have to divide the entire left-hand side by t squared. So that's just 2h minus 2 v naught t all over t squared is equal to minus g. I probably should have just made this easier on myself by dividing by a minus along with the t squared, which would just put a minus down here. Technically speaking, that's it, that's done it. Although you might want to clean up a little bit from here. Remember, taking the negative in a fraction in the numerator or in the denominator is just the same. And when you have two things being subtracted and you take their negative, it changes the order of subtraction. So if you were solving a problem like this in a textbook and checking your answer in the back of the book, they would have done that rearrangement and called it 2 v naught t minus 2h all over t squared is equal to g instead. Or maybe they would have rearranged further and put that g on the left-hand side where we usually like to see that sort of thing. As far as I'm concerned, that's not any better or worse, it's just different. But you should be able to see that it is the same equation, just written differently, because that is something that can show up when you're checking answers against sources in the back of the book or something like that. Right. In any event, that's all I have for you on this one. As always, thank you for joining me. I'll see you next time.